Let's see a code example of multithreading, and more specifically, the grocery store example that I mentioned in the last video. This example is pretty simple. We just have two classes, the first of which being this async example class, which is where our main method lives. And later I'll use the main thread to spawn other threads, and we can see how those work in parallel. But for now, I just have a simple for loop that will iterate 8 times from 0 to 7, sleep for 1 second, and then print out I to the console. So you can think of every I being printed as a person completing their checkout at the grocery store. So right now we're only using the main thread, so it's like we only have one register open. And a couple of side notes, thread.sleep is something you can call, and you pass it a certain amount of milliseconds, and that will cause the thread it's working on to pause. So calling thread.sleep won't affect any other threads that are currently running. And a few side notes, thread.sleep throws a checked exception called interrupted exception. So because it's checked, I have to handle it somehow, which is why I have it surrounded with a try catch. And also I'm swallowing the exception, as in I'm not actually doing anything in the catch block, which is usually bad, but I just have it this way for simplicity's sake. Normally I would have statements in the catch block to take appropriate action in case that exception was thrown. So when we go to run this, this should print 0 to 7 and take about 8 seconds total. Okay, so let's take a look at counter. Counter is a class that I made that implements runnable. What implementing runnable means is it means you have to override this public void run method. If you don't, our code won't even compile because it knows that we have to implement runnable.run. So, what implementing runnable does is when we go to make a new thread, we can give it an instance of counter. And because counter implements runnable, the new thread knows to call this run method when it goes to start executing on a new thread. So the code inside of this run method is the code that's going to be running on a different thread other than main. Other than that, the loop here is pretty much the same, except for it just counts from an arbitrary min to an arbitrary max that's specified in the constructor. So let's watch what happens when we go to run this on multiple threads. So rather than having main count from 0 to 8, let's just get rid of that. Let's make counter A to counter, and we'll tell this one to count from 0 to 3, and then counter B will be counting from 4 to 7. So if I run it now, nothing will happen because nothing's calling the run method. So we could go ahead and call those ourselves if we wanted to. We could say counter A.run and counter B.run. We haven't yet created new threads, so when we go to run this, it will finish everything in counter A.run before it moves on to counter B.run. So let's make a couple new threads. So we've made our counters, so thread A, thread, and we can pass it our counter because our counter is a runnable. So, oops, let's make thread B take our counter B. So we have our counters, we have our threads. Lastly, we need to start the threads, and we do that by saying thread A dot start, and then thread v dot start. So now let's watch the console. You can see that all the digits from 0 to 7 were printed, and it took about half the time. But like I mentioned in the last video, we don't really have control over which thread executes when, so it's out of order. But if you'll notice, the digits 0, 1, 2, and 3 are still in relative order, and the digits 4, 5, 6, 7 are still in relative order. So 0 is still before 1, which is before 2, which is before 3, and 4 is before 5, before 6, before 7. So each individual thread still maintains order. It's just when we have two of those working together, the order can be jumbled. And let me add a print statement here. So in this example, we have the main thread, and then we make two other threads. So the main thread doesn't go away, so we should see this print statement before all the numbers are printed. So that's a basic example of multithreading, and if you remember from the last video, I mentioned that some things can be multithreaded and some things can't. So if the problem we were trying to solve would be, or if it was counting from 0 to 7 in order, it wouldn't really make sense to multithread it, and it wouldn't really work. But if we introduce the problem of the grocery store line, we just have 8 people that we want to get through the checkout lines as quickly as possible, and we don't really care about the order. So the name for that is dependency. If we want to count in order, each operation is dependent on the operation before it, as in the operation before it must finish before that operation can start. So 7 depends on 6, which depends on 5, which depends on 4, and so on. With the parallel grocery store checkout example, there's no dependency between each person being checked out. Any person can be checked out at any time, and by opening more registers, we will complete everyone's checkout quicker.